In this application, we have an airplane that takes 5 hours to travel a distance of 3,300 miles with the wind. The return trip takes 6 hours against the wind. Find the speed of the plane in still air and the speed of the wind. So there are two questions being asked. We need the speed of the plane and we need the speed of the wind. We also need to know a formula about distance equals rate multiplied by time. If we know that formula, we'll be able to make some substitutions since we have some numerical values given that are related to distance, rate, or time. So again, I can set up a table with distance, rate, and time. We also know two different things about the wind. This plane is either flying with the wind or against. So I'll write WW for with wind and AW for against the wind. When I go back and read the problem, it says that it takes 5 hours to travel a distance of 3,300 miles with the wind. The return trip is going to cover the same mileage. So I can fill in a distance of 3,300 miles for both situations, with wind and against wind. It tells me right out that it takes 5 hours to travel with the wind. So the time with wind will be 5 hours. It takes 6 hours to travel against the wind. Again, 6 will represent the time traveling against the wind. What we need to know about the rate is that the wind does have some effect on the speed of the plane. So it's actually going to be a quantity that's filled in for rate. When you're traveling with the wind is going to help you. It's going to push the plane along. But when you travel against the wind, it's slowing the speed of the plane down. So we'll be subtracting that wind speed. So what we also need to know is the rate. It does not tell us anywhere in this application what the rate of the plane is. So that's my second variable, R for the rate of the airplane. W will be the speed of the wind. So I can form a system of linear equations in two variables with this information using our formula, distance equals rate times time. The first equation is 3,300 is equal to 5 multiplied by R plus W. The second equation is 3,300 equals 6 times R minus W. So I did switch the order of time and rate just because it's more standard form to see this single value written in front of a quantity. So what we'll need to do next is actually distribute 5 to this quantity and distribute 6 in this other equation. So when I rewrite those, I'll have 3,300 is equal to 5R plus 5W for that first equation. In the second equation, I'll have 3,300 equals 6R minus 6W. The elimination method is probably our easier method for solving this system. Unfortunately, 5R plus 6R will not cancel, and 5W minus 6W doesn't cancel either. So we will need to multiply the first equation by some number that will help us to eliminate either the variable R or the variable W. The second equation is also needing to be multiplied. So if I just look at the first variable R, can you think of a common multiple that 5 and 6 would have in common? If I start counting by 5s, 5, 10, 15, 20, 25, 30, 30 is a common multiple. So if I multiply everything in the first equation by 6, and I'll do that individually, and multiply everything in the second equation by 5, I can see that this variable of W will eliminate because I'd end up with positive 30 and negative 30. So let's rewrite these equations and multiply through. 3,300 multiplied by 6 will give me 19,800. That equals 30R plus 30W. In the second equation, multiplying 5 times 3,300 gives me 16,500 equals 30R minus 30W. And we see that W does eliminate. I'll have to combine my like terms now. I know I have 60R on the right hand side, and when I add these terms on the left, I've got 36,300. My next step to isolate R would be divide both sides by 60. R represents the rate of the plane. Dividing 36,300 by 60, I get a rate of 605 miles per hour, and that is the plane speed. I still need to figure out what W is. So to figure out the value of W, I'll go back to this first equation. 19,800 equals 30 times 605 plus 30W. When I multiply 30 times 605, that gives me 18,150. So I'm going to subtract that amount from each side of the equation. $19,800 minus 18,150 gives me 1,650 equals 30W. Dividing each side by 30 will leave us W, which is the wind speed. W is equal to 55 miles per hour. So we've got the rate of the plane, and we have the speed of the wind.